Hey, I'm Rob Taylor, visual artist and general maker of things, and welcome to another BR85 build skills video. In this one, we're going to be looking at the general stock area and the magazine, and how to make that removable in a relatively easy way. How to get in the back, and generally how to keep things accessible in a multi-part build like this. So yeah, let's get on with that. So first thing to do here is to open up the holes in the hollow casting with a deeper cavity like the mag well here. There's no real easy, straightforward way of doing it. You just sort of attack it until it breaks open. With a rotocast like this, the actual edge corners up at the top should be somewhat weakened, slightly thinner than everything else, just because of the way the resin settles inside while you're turning the mold. Drilling it out and then sort of attacking those edges with the screwdriver is what I was doing there. And then once it all pulls out, you can just clean it up with files. On the back, I don't actually want to take out that entire strip. So I'm measuring up against the plug that I specifically put on the cover to mate into the hole that I would be cutting into this. It should grip it a little bit and keep it nice and aligned once it's all in place and assembly's finished. Since this is all straight lines, the easiest way to do it was just to zip cut it with the Dremel Easy Lock plastic cutoff wheel, which work really nicely on smooth cast resins. So on the BR85, the magazine is actually too big for the stock. Not just physically, but also on the game model. But that's pretty easily fixed by cutting a hole in the roof of the casting. It just needs to be the size of the round sticking up above the top of the mag. Then once all the holes are cut, everything seats together nicely and compactly, and is ready to move on to the next stage. Alright, next step is to deal with the magazine itself. I missed some recording here for some reason. I'm not sure what happened to that footage, or if it was ever recorded. But all I did was drill some, I guess, number 6, I think, size holes, enough that the threads would grip onto, and then counterbore at the diameter of the magnets. These are countersunk ring magnets, so I just apply the epoxy and screw it all back in, and it's good to go. Then it was just a case of filing down the button head screws that I used to fasten in the magnets, get it all nice and flush, and try and get the metal dust out of there as much as possible. Now that the magnets are installed in the removable pod, we can measure where they're going to line up in relation to the main body, and drill any access holes as necessary. You can see here that the top magnet is basically free floating in there, so don't need to drill that hole. Since we're going to be covering most of the inside here in polyester resin, gotta try and protect everything that we don't want it to stick to, and the best thing for that I've found has actually been this really bad plastic wrap that doesn't actually stick to itself. Useless for food, pretty good for prop making. When you're doing this bit, it's worth taking a bit of extra time to make sure everything is pulled as taut and skin tight as possible, since you want the fiberglass flange at the end to mate up with the removable part as tightly as possible. And there you can see both of the magnets visible, the lower one through the access hole that we just drilled. Obviously, when you're dealing with mating parts like this, it's important to not only protect the parts, but make sure they're absolutely locked into their final position that you want them to magnetically mate into. If you leave it kind of loose and sloppy while you're putting the fiberglass on, then there's a pretty good chance it's not actually going to mate up properly once it cures. I don't know if there's an official optimum size you're supposed to use for fiberglass cloth, but I found that 1 to 2 inch squares work really well. Surface tension makes the inside of a rotor cast really shiny, so I'm scratching it up a lot with the point of a needle file. Always pays to check your hardness to resin ratio. Make sure it's right. You don't want it to get in there and harden instantly, and you don't want it to never harden, so pays to be sure. These cheap weight party cups actually melt from the polyester resin over a few hours, but for the 10 or 20 minutes of pot life, they work just fine. But just something to be aware of. Once it starts setting up, you need to get it somewhere where it melding, falling apart, and sticking to whatever's underneath it isn't going to be a problem. Since it's a little hard to tell what I'm doing in there at this point, I'm going to introduce a visual aid while I key up this magnet surface. So we've seen the position of the 2 magnets on the magazine, our removable object, inside the body of the stock, our fixed structure. So what I'm trying to do here is lay down an initial sort of skim layer, essentially, over the magnets of the magazine, which will be sufficient to hold more magnets in place and prevent them from being pulled through when you remove the magazine. This isn't intended to be anything super structural, it's just to hold the magnets in place. So then when we add more fiberglass layers on the other side, we can complete this structure, and it'll actually support proper insertion and removal of the magazine. In essence, it becomes the magwell that was impractical to cast in the first place. The main reason behind all this is that nickel-coated neodymium magnets are kind of difficult to work with. They don't like being superglued or epoxied all that much, and if you can sandwich them from both sides and completely physically prevent them from moving, you're going to be a lot better off. Now here you're going to see the actual intricacies of the manipulation of the fiberglass that I was doing inside the stock itself. But this is obviously on the chamber section, intended to actually hold the stock cover to the body of the BR85. I removed the paint with the little ball grinder bit, but it didn't really leave much of a surface for the polyester to really stick to, so I keyed it up more thoroughly with the sanding drum. Since this was going to be retained by fiberglass anyway, it wasn't really the biggest deal in the world to properly key up the outside surface, but I figured it couldn't hurt. Okay, so now you get to see the actual process. First thing to do is to get a good layer of polyester down on the surface, get it in all the nooks and crannies, make sure it's going to really well mechanically bond to the substrate. And make sure there's enough on there to start soaking into the fiberglass when you place it from the backside. Then once you've got the fiberglass in place, you can start pushing more resin into all the voids and forcing it into the layer of polyester that you already put down. You see here that I'm using a really short, sharp dabbing motion rather than like stroking it on. That's because the fiberglass wants to kind of cling to anything with resin on. And if you stroke it, then it'll pull it out of position and get resin everywhere. As you get more resin on, it gets more and more transparent, just like regular fabric, so it becomes actually easier to see what you're doing over time. To make the mating part for this one, I'm going to transcribe the measurements across with calipers. Make sure it's all centered up, and the magnet's going to sit exactly in the cover according to where I need the cover itself to sit on the body. It's really the force of the magnetic attraction that's keeping everything in its specific location once it's in place. Easiest way to do pilot holes I found is actually just use a Dremel, since you can use it like a pencil and really support it. You can get in pretty pretty precisely, sometimes even more so than you would with the drill press. Then it's just a case of opening up the hole to the 1/2 inch or whatever diameter of the magnets. With a drill this size, it's a little easier said than done. You don't want to suddenly grab the resin and rip all the way through, which is quite easily done with urethane. You kind of just got to sort of dab and back off. Sometimes to clean up and deburr, I'll even run it backwards. Then it's just a case of checking the alignment, and we're ready to start the process again. Gotta get a good surface there around the magnet. Double check the polarity of the magnet, and then you can use the actual scuffs on the surface once you've keyed it to double check that polarity if you only do it on one side. I'm keying it and supergluing it anyway, just because even though we're relying primarily on the fiberglass to keep it in position, it's always better to go with 2 systems of fastening than 1, just to have some redundancy. You don't want it ripping out once it's already been shipped out to the client. And then it's the 2-layer polyester, fiberglass, polyester again, and it's done. Pause here real quick, you can see the fiberglass and the magnets in there, embedded within that layer of fiberglass. And how satisfying is that to thunk? Works perfectly, doesn't come loose, can still be taken out. Okay, I hope that was useful and interesting. Couple of more things to note on top of what was in there. On the original test build, I put the magnet in the base right there. You may be wondering why I did the whole slidey up and down thing. That was because when you do magnets, when you pull them apart like this, it's a lot more force, so I could get away with a single one, hence why it had to be 2 when it was sliding. But the problem with a lot more force is that it requires a lot more holding power to keep it in there. And really all that was in here was a bit of epoxy, and it, like I was saying with the nickel coating, it doesn't really do a whole lot. If I'd done the fiberglass sort of played over the top, it might have helped. But then you risk reducing holding capacity and the magazine falling out. So in the end, I think definitely better to go with the sliding system there. Quick safety note, obviously, fiberglass, polyester resin respirator. The other thing, with magnets in general, they aren't just useful for fastening things, you can also make mechanisms with them. As some of you may have seen, the safety on the NN14 is actually a magnetic mechanism, it's not a spring-based mechanism. So that should be something to look at in future videos. Okay, final note, this is going to be the last BR85 video. Obviously there were several other aspects involved in building it, but they're really kind of redundant based on the 3 that I've already done. It was really just variations on a theme, so I just want to draw a line under it there. All of that video was shot a year ago or more, and there's only so much I can squeeze out of it. So yeah, we're going to move on to future projects. I'm going to do some NN14 stuff, because I know everyone wants to see that. And we'll see what else is going to happen. There are some exciting developments afoot here, so that will lead to some new opportunities. So yeah, that's it. Once again, hope you enjoyed that. Thanks for watching, and I will see you on the next one.